our Lewis definition of acids and bases. Again, same guy that invented Lewis structures. One a great scientist, should have got the Nobel Prize, but he didn't. Again, I'll leave that for I'll leave my opinion out of it. But anyway, um, G.N. Lewis said that an acid is an electron pair acceptor in an acid-base reaction, and he said base is an electron pair donor. Now, for those of you going on to organic chemistry, this definition is insanely important. This is actually going to be the beginning of arrow pushing mechanisms. So, for example, if we looked at this reaction between BF3 and NH3 to make this guy, this product over here, the Arrhenius definition and the Bronsted-Lowry definition are not going to tell us that this is an acid-base reaction, but it actually is. Okay, if you look at the Arrhenius definition, there's no H plus or OH minus, and the solvent might not even be water, right? And if you look at the Bronsted-Lowry definition, there's no conjugate pairs, right? These two things go to one thing. Okay, but this is actually an acid-base reaction. Here's why. If you look at the Lewis structure, the nitrogen on NH3 is donating its lone pair to make a new bond between it and the boron. Okay, and an electron pair donor is a Lewis base. And the molecule that accepts that lone pair, this boron is accepting, so BF3 is accepting that lone pair, that's a Lewis acid. Now, the Lewis definition will work on everything that the Bronsted-Lowry and Arrhenius definitions work on. So I want to prove that to you. So let's just do the ammonia and water one. Let's do that. So what I actually want you to do first is I want you to use the Bronsted-Lowry definition to identify the acids and bases. And if you want to do the conjugates, that's fine too. So let's say we have a reaction between NH3 and water to make NH4 plus and OH minus. I want you to first apply the Bronsted-Lowry definition. So I want you to make pairs, and I want you to tell me using Bronsted-Lowry who's the proton donor, who's the proton acceptor. And then we'll draw Lewis structures, use the Lewis definition. Go ahead. All right. So pair, NH3 accepts a proton. That's what bases do. Water donates a proton. That's what acids do. And again, that would be my conjugate acid. We're going to abbreviate that Ca because this is a base. And this would be my conjugate base because its conjugate is an acid. So awesome. Now what I want to do is I want to draw the Lewis structures. And I want to try to do an arrow pushing mechanism here for you. This takes a little bit of practice. Again, if you're going to move on to organic chemistry, I would super pay attention here because you're going to have a head start. This is like all of organic chemistry is arrow pushing mechanisms. If I draw the Lewis structure of NH3, it looks like this. And I'm just going to draw the regular old Lewis structure. Not going to draw it with the molecular geometry. It is a trigonal pyramid, right? But we're just going to draw it like that. You don't need molecular geometries to be able to do the Lewis definition of acids and bases. Then we're going to draw water. And it's going to go to NH4 plus. So we're going to draw that Lewis structure. And OH minus. We'll draw that Lewis structure. And now I want to talk about what must have happened in this reaction. How did these guys react? Well, if we look here, we get a new bond between nitrogen and hydrogen. So we originally only had 3 nitrogen hydrogen bonds, and now we've got 4. So this is new. And if we look at the oxygen here, it originally only has 2 lone pairs. Now it has 3 lone pairs. So this is new. So what must have happened? Well, here's what happened. The nitrogen used its lone pair to make a new bond with one of these hydrogens on water. Because hydrogen can only make one bond at a time, as soon as it makes that new bond, the electrons that were in the bond between oxygen and hydrogen now go back onto the oxygen. And that's how we get this new bond right here. That was the electrons being shared in this NH bond. They were originally that lone pair on the nitrogen. And the extra lone pair on this oxygen, they were originally being shared between hydrogen and oxygen. And now we can apply the Lewis definition. Lewis says a base is an electron pair donor. So this is donating its lone pair. That's the base. And Lewis says an acid is an electron pair acceptor. This molecule accepts that lone pair. That's my acid. Now, traditionally in Lewis theory, we don't have conjugates, so you don't have to label the conjugates. That's a Bronsted-Lowry thing. Okay, but yeah, the different definition. Lewis definition is great if you're fast at drawing Lewis structures. If you're not quick at drawing Lewis structures, then it's not so great.